Alright, Bismillahirrahmanirrahim. Let's start with our presentation. First of all, Assalamu alaikum. Before you guys, there was the class 10 over here, boys and girls both. So I had one presentation with them. And one of the reasons why I've come over here, and you can see a telescope that is over here.
So class 8 is the
whole class. The whole class. So it will be a good idea that I start the things. I start the thing when they come. So before my start, she has already told me that she knows what this thing is, and she has got an idea about this thing. It shows that she must have had some interaction with a telescope, either live or videos and pictures and stuff like that, or someone must have observed. Have you ever had this question in your mind that you should be looking at a telescope, looking at the sky?
Yeah, actually, Monica, because there is a place in New York where there's a huge bridge or something, and there are a lot of telescopes over there, and they're very huge, and through them you can see all the seagulls.
Are you talking of the ground observatories that are over there? There are huge telescope domes, and then inside the dome there is this telescope, or there were the small ones.
No, there are a lot of telescopes placed in the bridge. So.
All right, on the bridge.
Yeah, on the bridge.
And you can use them also for looking at the sky, or you can look at the far off things as well.
Yeah.
And tell me, where you pointed your telescope? To the sky or looking at the
No, I didn't. I actually saw this in a movie.
Alright, that was in a movie.
Yeah.
But this is the real thing, and I'll be telling you something about that. And inshallah, we are going to have a very good discussion on the topic of telescopes. So, anyone else sitting over here, you have had any interest looking or buying a telescope?
I have a question.
Yeah.
Like a human eye, when someone wears glasses, a human eye cannot see that far. But how can a telescope can show us the space, which is so many kilometers away?
Yeah.
What type of lenses?
Yeah, I'll tell you that. Kilometers is quite a small word for space. Kilometers is quite a small word for the world around us as well. When we are talking of the space, we normally even go to the extent of talking about a light year. You must have known the distance traveled by a photon in the whole year is 1 light year. So when we are talking of the space, when we are talking of the universe, we talk in terms of light years. And even when we are talking or referring to light years, sometimes even light years become irrelevant, because then we are talking of millions and millions of light years. For example, the nearest galaxy to ours, our galaxy is the Milky Way galaxy, right?
Yes.
We live in the Milky Way galaxy, and that Milky Way galaxy is 100,000 light years across. So if photon is taking around 250,000 miles per second, which is like taking 1.3 seconds to reach the moon, and 1.3 seconds to come back, or in 1 second, if the light is traveling 7 times, rotating the whole earth, it means that the speed of light is quite big, right? So, once we talk of the concepts in the universe, even that speed is not enough. Even that speed fails to tell us about the immensity of the universe. We fail to grasp. Now, your question basically was that with the help of this telescope, how is it that we can view space, which is so many light years away, right? So, I won't use the word kilometers or miles, but light years, so many light years away. Well, space is a very general term. We will wait for just a few seconds so that we find all of them are seated. Please sit down.
Move on, girls, hurry up. ये स्कूल भी निकालते हैं, स्कूल भी पढ़ाते हैं।
Alright. The last person entering can close the door. Just get yourselves comfortable wherever you are sitting or standing, because this is not going to take too long. For some fortunately, for some unfortunately. But let's continue. Before you guys came in, I was, you can see over here, we've got a telescope that you can look at, and we have got. First, I'm going to tell you why I am here. What's the purpose of me coming? Alright. The government has launched an initiative, and that initiative is we will be putting different A category telescopes in different colleges, government colleges. Our government college at IMCB Pakistan Town has already been selected for a very big celestial telescope. Once that telescope is set over there in our college, we will be inviting different students from different schools and colleges to come and visit our college for celestial observation. But before that happens, I thought it is a good idea that I start my presentations with no other school than American Lycetuff because of my association with American Lycetuff. One of the reasons why this telescope has been brought over here is that this is called as a primary telescope. This is primary because it has got all of the features that any basic telescope should have. We use telescopes not only to look at the sky, night sky, but also look at the far off things as well. The telescope has got basically following main features. The first one, the tube section over here that you can see, it has got different lenses. If you have gone through your study in physics, you must have gone through the concave and the convex lenses. What lenses do is that they do the trajectory of the beam of light into a singular point. Once it does that, it magnifies the image of the object in a very specific way. So what the telescope would do is that it puts into focus all the photons that are emitted by any of the object on a special lens over here. Now I am going to show you how it is done. This is basically the tripod stand over here. This stand is basically in order to give stability to the telescope while we are looking at it. Now remember this thing, although this looks to be quite a basic telescope, I have already discussed it in my book, which is over here on time travel, concept of time travel by me, that this telescope is still better than the telescope used by Galileo. Because at that time, he didn't have that much advancement in lens technology. So a lot of gadgetry has gone up, and this gadget that you see over here should not be counted as a basic telescope only. I am going to show you how to use this telescope and why to use this telescope in my second phase of presentation. Now over here, this piece goes in over here. This has got certain locks. Once I secure it over here, because the image is inverted, because of the lens that is over here, any object that I see in the sky, it will have an inverted image. Just like our eyes, when I am looking at you, you are looking at me, the brain gets the inverted image back into the main focus area, and then we see the image upright. But the image that is casted at the back side is not straightforward, it is an inverted image. So what this does is that it puts the image back into its position, and then we have got certain lenses. Now you should know, first I am going to ask you this question, do you know that there are different planets that we can see with our naked eye without the use of the telescope?
Jupiter.
Anyone?
Jupiter. Mars.
Jupiter?
Mars.
Mars? Venus. I asked you a question. How you say Venus? Is it like abruptly it came to your mind and you said Venus, or can you tell me? This one planet, Venus, this is that one planet that anyone and everyone can see with the naked eye. You must have seen it. All of you must have seen it once. This, the shiny star that comes first up in the evening and goes last in the morning, is not a star. It's the planet Venus. So after the moon, the shiniest thing, the shiniest star in the sky is planet Venus. And we can look at it with our naked eye. And that is also the hottest planet. Wait a minute, is it the hottest planet?
Mercury is the yes. Mercury is the
Mercury. How can you say Mercury is the hottest planet?
because it is closest to the sun.
But you know, there is a surprise for you. Mercury is not the hottest planet. Venus is the hottest planet. Why? Someone is coming up with an answer.
Because it traps heat.
It traps heat. Because of all the carbon, the methane, it traps heat in its atmosphere, and that atmosphere cooks it to such an extent that it glows white plasma hot. So Venus is the hottest planet, and that's one of the reasons why whenever you look at the Venus, it is the shiniest star in the sky. It's not a star basically, but because just in order to give you an idea of what Venus is, this evening when you go back home, when there is no star in the sky, the first star that is going to appear is going to be Venus. The first star is going to be Venus. Go look at it. So one of the important things with this telescope is you look at the Venus, and instead of a star, the whole planet is going to come in front of you like a full moon. And you can't see anything. It's just going to be a white blot. Nothing more than a white blot. So that's planet Venus. Then there is something else that you can look with this telescope, and that is called as the red planet. You know what the red planet is?
Mars.
Mars is called as the red planet. Mars was also called as the goddess of war in the Greek times. Venus was called as the goddess of beauty in Greek times. Yeah? Because they didn't know what that was, so they used to term everything like the goddess of this and the goddess of that. Next thing that you can look at with this telescope is Jupiter. Jupiter, what is famous with Jupiter? Its moons, Tritons, right? But not the rings. The rings are with the Saturn. With the Jupiter, the big storm.
The red
big
dot.
storm.
The red dot.
The red dot is called the big storm, and it is so big that the whole of the earth can go inside that red dot. It's so big. Jupiter is so big as compared to the earth. So Jupiter is the giant.
But what causes the storm?
And what caused the storm? The gravitational pull of Jupiter. Jupiter is normally classified as a small star that failed to ignite. It is a gas giant, right? You know what gas giants are? Jupiter is a gas giant. Saturn, Uranus, they are all gas giants. The only thing that separates them from becoming a small star is they failed to ignite. Alright? One of the reasons why I brought this telescope over here is also like, before talking to you, before having a conversation with you, I had conversation with my own students as well. I found out that most of the people, most of the students, boys and girls, they've got this one aim in their mind. Once we are done with our first year and second year, we'll be doing BScs. 90% of the girls and the boys, they all already have this programmed in them. One of the reasons is that I need to urge the young lot to look into different other fields as well. astrophysics, astronomy, space technology, arts. Not every person is destined to become a scientist. So we need to get out of the box of thoughts that we have been put in. Each one of us has been put into a box of thought, and we are not trying to get out because we have been told to stay in. Because we have been told that the more we stay in, the more comfortable we get. The more comfortable we get, the harder it is to get out. So, new sciences, emerging sciences are the fields welcoming you. You must have seen that there are certain students who, even if they try, they are not good in certain subjects. Even if they try. One of the reasons is that they do not have that mental approach. But what needs to be told to them is that the subjects in which you have the mental approach, take those subjects. Unfortunately, we are not encouraged to take our own line, own thought, own ideas, because we have already been told that what we tell you is always better than what you know yourself. Then what happens? Open up to new fields, open up to new subjects, and sometimes something is going to click in your mind that this was the subject I was destined for. Basically, I've done my MPhils in American Studies. And people kept on asking me how you came on this topic of time travel. This is my book, Time Travel, right? How you came to this topic of time travel? Basically, that's the concept that people teaching physics should be talking about. But I came to this concept because I thought about it. I kept the interest in me alive. I said to myself that nothing is going to stop me from becoming what I want to become. So once you speak to yourself, once you believe in yourself, nothing can stop you. Your teachers don't know you. I don't know my students. I can't judge them. I can't judge my children. You are the best judges of yourself. So, when you are looking at the topic, always look at the topic with open mind. Over here, coming over here, when I talk to the 9th and 10th classes, 10th class was here before you guys. I was amazed. There were certain things about space and telescopes that they didn't know about. And I don't blame them. I don't blame them. I'm just saying that we should not limit our thoughts only to the things that are there in the books. But we should have an urge to know more, to pursue our desires. Next time you look at the bright sky or the night sky, do not look at just the blue horizon, but look deeper. We should have more scientists going to NASA than any other field. We have got a lot of doctors and engineers. Why not scientists? Why not people who have got interest in space, objects in space? For example, nanosatellites. You know what the concept of nanosatellites? Anyone? Small satellites weighing from about 2 kg to 7 kg sent into space. And by the way, Pakistan has also spent a nano satellite in space, and that was around 2022. But we don't know that. We don't know that. How many space missions have gone to Mars? Anyone? Any idea? Rover missions? Anyone who knows about Voyager 1 and Voyager 2? These were the first launch vehicles to probe the solar system. In late 1960s they were launched, and they are traveling at around 35 kilometers per second. And they have just gotten out of the interplanetary system. They are still near the Oort cloud. So, this is a good investment. You should have this at your home whenever you are free, whenever you need to look at the night sky, whenever you see the streaks of light. You know, when you are looking at the night sky, there are always streaks of light. They just come for a second, they glow, and then they are no more there. What's that? Comet? Yes? Anyone else? Anyone who can try? What is it? What is that streak of light?
It can be a shooting star.
Shooting star. Now the concept of shooting star, I want to address this concept of shooting star because this is so much popular concept. This is such a popular concept that there are certain concepts we say that they are so popular that they are being included as ones that are true. There is no such thing as a shooting star. Stars do not shoot. Stars do not, fall down. They don't race along in the universe. They stay there. They spin. Everything is moving in 3 or 4 dimensions, right? So that's basically a meteor entering the atmosphere of the earth every day. Right now, even if you are standing over there in your playground, you see small dust in the sunlight. You know, all of that dust is not the dust of the earth. It is also space dust. Every second, so many meteors are entering our atmosphere and burning up in the sky. But we don't realize it. It's only in the night time that we look at those bright streaks of light. You know what killed the dinosaurs?
You're right.
An asteroid. How it killed the dinosaurs? By entering the Earth's atmosphere. They keep on. Every night there are thousands of meteors entering our atmosphere, burning up in the sky. Yes.
Because the asteroid was so big.
It was so huge that our atmosphere failed to burn it down. And it impacted the Earth at around 60,000 miles per hour, equivalent to 15,000 Hiroshima bombs. But all of the dinosaurs didn't die because of that impact. Just a few of them died because of that impact. Rest of them died because of the cycle that it started. First, the impact sent so many trillions of tons of rock and debris into the space, and then it started raining back on Earth. And as the Earth is spinning around, even if that impact was somewhere on the far side of the Earth, the impact of the other rocks raining down came on the other side of the Earth. So all of the dinosaurs, they were wiped out. Who knows about asteroid belt?
It's around the Earth.
Not around the Earth. It is between Mars and Jupiter. And there are billions of asteroids around there, and any one of those asteroids can enter the Earth's orbit. You just don't know. You just don't know that. Which one is going to come and when it's going to come. But let's come back to the topic of the telescope.
So is that little rock that enters the Earth's atmosphere and falls on the ground that made the dinosaurs fly? Is that an asteroid or a meteorite?
Basically, it was an asteroid then categorized into a meteor. A meteor is the one, any rock that finds its way to the Earth, whether it was an asteroid, becomes a meteor, right? Now, looking at this telescope, it has got the tube which has got the concave and the convex lens, then it projects the image over here, it inverts the image and makes it upright, And then we have got two types of lenses. We have got the two types of lenses. As you can see, I am going to show you. If you look at the screen over here, you will find a small, very narrow dot, right? That's the lens we use for looking at the planets, right? Because it has got a lot of magnification. Then we have got something very special to look at the moon. This lens, which you can see clearly, right, in the backdrop. But remember, never use this lens without this. This is basically called as the filter. We use the filter so that the light of the moon should not, damage our eye, because it focuses the light in such a way that you look at the moon so clearly. So what we do is, number one, no matter how much expensive sunglasses you're wearing, no matter how much, never look at the sun. Even for the sake of fun, never look at the sun. It will damage your eye in such a bad way. So this lens is not meant to be looking at the sun, but for the moon. So what we do is that we fix this lens over here. Now it is safe enough for us to look at the moon. Now if you look over here now, you'll see that everything becomes greenish. Without the lens, you will see how it disturbs your eyes. Right? So now I'm going to put this lens on, and once I get this lens on, what I will do is that first I am going to find where the moon is. So without the lens, I am going to keep on focusing until I see. Now if for example the moon is over here, I've seen the moon, I am going to put this lens on top of it, it will slide down. Then I am going to lock it in place. Then I am going to focus it with this knob. At some place the focus is going to be perfect. The focus is going to be perfect. Wherever that focus is perfect, I'll leave it. Once I leave it, I keep on looking at the moon now, and it will show me the moon in such a perfect way that I can see any and every crater that is there on the surface of the moon. I'm done with it. Now I need to look at the planets. So I'm done with this. Now I got this one. With this, I can view the moon as well if I need to go into more details. But with this, now I can look at the planets from far away. But now I say to myself that I do not need to see with this. I need more resolution. I need to look at the rings of Saturn. So I need to go deeper into space. So I've got this final thing with me that multiplies the resolution 1.5 times. So I'm going to put this, slide this into position, and then I can use any of the two, slide it in position, either this or this, and then make it focus like this, and then I can view the planet as well. If I look at the planet, if I look at Venus, it is not going to show me detail, it is only going to show me a white circle, that's it. Because it is so bright, yes, thank you. It is so bright that it only shows a white circle, nothing more than that. But if I look at the Mars, it is going to show me the red small dot. If I look at Jupiter, it will not show me the red spot, because in order to look at the storm you need a bigger telescope. I will look at the Saturn, but again not the rings of Saturn, because I need a bigger one. So once my own college has got a big telescope, space telescope, it will be a very big space telescope. I will invite you guys to come over there and look at the objects in the sky only to create an interest in you people so that you know about different other disciplines, so that you have interest in them, so that you can become a part of a profession that you have not thought of yet. Because unfortunately, over here the choice of professions is very much limited to the students. Computer science, computer science, computer science, or medical of course. Doctor, computer science, doctor, computer science. That's it. So the choice of subject is extremely important. There are different new fields. For example, I have already told you aeronautical engineering. I have already set up aero modeling club at my college, just in order for the kids to know about aerospace. So satellite engineering, aerospace, satellite engineering, aero modeling. Then we have got this space technology, satellite engineering, artificial intelligence in satellites. So think about this. Even if you do not want to be a part of these disciplines, yet you should have interest in it. You should have interest in looking at the sky. You should have interest in trying to find out more about it. In this book, Time Travel, Practical Application in a Pre-Ordained Multiverse, I have talked of one of the hypotheses. I was talking to the class that came just before you guys came, and I asked them that anyone who has got any idea of the law of conservation of energy. Yeah? 9th class? 8th class? Law of conservation of energy. I have already asked this question from the 9th and 8th class. Law of conservation of energy states that energy can neither be created nor destroyed. It changes form from one to the other, right? Energy cannot be created, it cannot be destroyed, but it changes its form. So you cannot create it, you cannot just make a spell and it gets created. So if energy cannot be created nor destroyed, and science believes and science has told us that all the energy that the universe is using, or the universe has used, or the universe will use, has come from the Big Bang. The Big Bang, the creation of the universe, right? This is an accepted theory of the scientists that Big Bang was possible explanation of the start of the universe. This is what the theory is, that the whole universe came into being because of an immensely small point, smaller than an atom, exploded into everything in 10 raised to power minus 22 of a second. How? Science says, well, we have got different scientists working in Europe's CERN particle lab in order to still trying to find out how it happened, but they don't know. Even science tells us it has got no idea how a Big Bang happened, but they know it happened. So science doesn't tell us everything. Science has got certain loopholes, it doesn't tell us everything. It can't. Because it goes against the law. If the law says energy cannot be created, and all the energy that we are using, there is an apple. You want energy, you eat an apple, right? You eat an apple, that food becomes an energy, and then you do a work. You have to do a work because you have to get that energy transformed into something else. So I use this energy to push this thing. It has got a change. So all the potential energy got a storage in position X. But I got the apple because the apple I got from the plant that used sun's energy to grow. Alright, where the energy from the sun came? It formed out of the gases, converting hydrogen into helium fission reaction that is going on in the sun every second. Alright? How did the energy in the sun came from? A gas cloud. Okay, fine. Where the energy in the gas cloud came from? Well, it came from another gas giant out of the Big Bang. Alright. How did the Big Bang create energy? Well, that you know. How the energy was created in the Big Bang, we have got no idea. So, one of the reasons that I discussed in the book is that energy was not created at the Big Bang. Because science can't justify it. Energy got transferred into this universe from another universe. Because then the law of conservation of energy stays. That's why I believe that we live in a multiverse, not a universe. A multiverse in which the laws of physics for each universe is different. What I will be doing is that I will be giving 9th class teacher and 8th class teacher one of the books that she can keep with her, so that once you go back to your classes, you can give that to your teachers, and you want to look at the book, you can look at the book. And any 9th class students, any Sia sitting over here, one here, you keep it with you, alright? And then 8th class. Who's the Sia? Nobody? Korea. Would you like to give this to your teacher? Tell them it's from your daddy. She's my daughter. Yeah. That's one of the reasons why she is not smiling. So, Korea, give it to your teacher. And if anyone wants to ask any question at the end of the presentation, your team talks.
Is time travel actually real?
Time travel. One of the important questions that we face when I'm presenting the book in the university is time travel real? Does science allow traveling in time? Well, it's like asking a caveman 5,000 years back if it is possible to look at a person 5,000 miles from here. He's gonna say, "Are you nuts?" But now, with this technology, we can talk to someone in America in a couple of seconds, right? So, we are not saying that it's not possible. You know, time travel is happening right now as well. How? I'll show you how. Light. It is because of light that we are looking at each other. It is because of the photons that is between you and me. That's one of the reasons. Our eyes are not real. Our eyes are not creating images. They are only developing images. It is not because of the eye. The eye is only there to develop the image that is already there. Alright? I'm looking at this computer screen not because of my eye. My eye is only processing the image. Right? If there is an explosion on the surface of the sun, or if hypothetically, if the sun disappears right now, we will not be able to look at the disappearance of the sun for a whole 8.5 minutes. Why? Because light takes 8.5 minutes to reach the earth. So last time, if I take the sun away, the image of the sun will remain for 8.5 minutes. We will keep on looking at the sun. It's like if I say this is the fan over here, if this is the sun. Now the fan is working, but if I take away the fan, I keep on looking at the fan. How is it possible? But because the speed of light The photon that started traveling from there has already started traveling, so I'll keep on looking at it. So this is time travel. I'm looking at the sun, not the way the sun is right now, but the way the sun was in the past. Now, imagine that the nearest galaxy to ours, Milky Way, is Andromeda M31. It is 2.5 million years ago. 2.5 million light years away. We are looking at Andromeda galaxy not the way the galaxy is right now, but the way the galaxy was 2.5 million years ago. Now, if hypothetically we are sitting on Andromeda galaxy, we are sitting in Andromeda. Let's suppose we are sitting in Andromeda and we have got a telescope, hypothetically, and that telescope is so strong that we can, now I am standing at Andromeda galaxy. I am looking at the Earth. For example, that screen is the Earth. I am looking at the Earth. You know what I am going to see? I am going to see early mammals roaming on Earth. Because that is how the Earth would look in the telescope if I am positioned at Andromeda galaxy. Because I am 2.5 million light years away.
You can see the image that was captured to the camera.
Exactly 110% right. Now, let's take this assumption one step further. If I have the power to travel faster than the speed of light, let's say 100 times, and as I look at the image, I put this telescope down and start running towards the Earth at that moment, what is the Earth that I am going to find? Mammals, early mammals. So what have I done? I have traveled time. I have traveled time. The only thing is that, yes, it's a bit complicated, but still, if you think when no one is around, if you think, did you get the idea? The only thing that we require is an X force that breaks the speed of light.
And then we'll give it all the pass.
Theoretically, yes. Theoretically, I say, because right now, practically it's not possible. But who knows? Who knows? Things that were not possible. Think of the Greeks who used to attach wings to their bodies and they used to jump off the cliffs and of course fall to their death, trying to fly, and people would call them madmen because they gave their life. They told them that man cannot fly. Right now, man can fly. That's one of the reasons why the Earth is now not a big place anymore. You can travel from one place to the other in 24 hours. All you need is an airplane. But a few hundred years back, that wasn't possible. Right? So,
I have a question.
yes, please.
Like, time is always going on. It never stops.
It never stops.
But, for example, if it stops, will we be able to see everything around us, or we won't be able to see?
First of all, when we say time, the only thing that comes to our mind is clocks, digital and stuff like that. What actually is time? If, for example, I take all the watches away, put them down, how can we have a sense of time? So the only thing that we know of is a ticking of a clock, right? What if that ticking of a clock slows? I'll give you an example. According to science, if there are two clocks, so accurate that they are atomic clocks, they have got the same time, and if I keep one stationary over here and start taking the other one and start moving it, because of the inertia, the time of this is not going to be aligned with the time of that. Time is relative, not absolute. The time for a moving person is always going to be relevant to his position. I am going to give you an example. This is the example. Take a very good look at me. Let's say that the key comes back exactly 1 second as I throw it in the air. Alright? And let's assume that it is taking 1 foot while in the air, right? 1 second, 1 foot, right? Now take a look. Again, it is taking 1 second, 1 foot, but it is traveling farther because now it is traveling not only in this position but also in this position. So the travel time for this key is much more than the travel time of this key when I was stationary. Therefore, time, distance and things are relative to each other. They are not absolute. I'll give you an example, final example. What is an absolute value? SI units, Systems International. In Systems International, what is considered as a meter? Tell me. What's a meter? How do you define a meter? What is 1 meter? 1 meter. Of course it shows the distance. How do you measure a meter? A meter is the distance traveled by light in 1/100th or 1000th or something of a second. So we have taken the speed of light to be so much accurate that we determine what a meter is based on the speed of light. But here is a trick. Nobody has measured the speed of light. You are surprised? You are surprised that the basic fundamental concept of physics, which is the speed of light, which is given in your science books, nobody has measured it, but in your science books it has been written that the speed of light is this. How they have come up to so accurate speed of light? It is always a reflected measurement of the speed of light, not one-way journey. Nobody, no human being has ever recorded the exact speed of light in one direction. It has always been reflected off the mirror and back to the observer, and then they have made the calculation if the speed, if the light took this much time coming back, so I am going to divide it into 2 and then this is the value. You know why scientists have done it? It is because of that the time is relevant. If for example I am one person and I say I am going to determine the speed of light, I got a laser. There is another person 5 miles away over there, and I tell him that once you see the flash of light, hypothetically, you see the flash of light, you will just stop your timer. Now there are different problems. First problem is that my clock and his clock will not be aligned. Well, you can say that both clocks can be taken to one place, you can just align them and then this clock can be moved over here, right? But there is a problem. If you start moving this clock, then according to the rule of physics, once it reaches over here, because that clock is stationary, this clock has moved, it will not be aligned. Second is, you align both in the center and then move the clocks away, move this clock over here and this clock over here, but again, moving clocks will not align. The universe is full of mysteries. The universe questions science, the way science questions the universe. Therefore, the universe is full of extraordinary things. And because all of you are young, you should have a mind that is open to questions. For example, on this subject of space, you have never thought of before. Start thinking about it, irrespective of whether it is your subject or not. This is not my subject. I wrote a book on it. English is my subject. I've done my all of the qualifications in American studies, defense and strategic studies. But keep your vision, keep yourself alive in your heart and your mind, no matter what you do, no matter what you go into, whether you become a doctor or not. You should know, because this is your duty. You come over here in this world and try to find out the answers to the questions that have already been, put over here. We haven't come over here in this world just to become doctors and engineers, that's it. Ask questions, explore, and take the profession in such a way that every new day, for example, every new day, I am talking to students. I am going to different colleges and talking on different subjects. So I keep myself alive. I don't limit myself only to teaching of English. That's it. That's going to be pretty boring if I do it. Therefore, just don't become doctors and engineers. Become sparking people. Alright? Questions, if any? Ask questions. Come on. The more you ask questions, the better it is.
As you told us that the universe also questions science and science also questions the universe.
Yeah.
And you told us that the energy in the Big Bang was transferred from another universe.
Yeah.
But where did that energy come from?
Yeah. At
Does
least,
science know about that?
The science only tells us that energy can neither be created nor destroyed. This is what science says. And then science keeps silent. Because when we ask them, okay, fine, if energy cannot be created, how come energy got created in the first place? Because you told us energy cannot be created. But it got created in the Big Bang. They say, yes, it got created. How? We say, we don't know. Let's just move out, and after the Big Bang we can tell you. But we say, no, tell us from the Big Bang. So my hypothesis, please, when this book comes to you, do look at the book. And if you have got any further questions, I hope that it answers some of the questions. But if you have got further questions, you can always ask your teacher. They can invite me here anytime, and I can be here for any question answer session if you want. But it will be a lot better that once you read it, you get the idea that I have in my mind, and then you can ask me questions. Anyone else?
There's this profession as well.
Scope. Remember, professions do not have scopes. No profession has got scope. Individuals have got scope. There are many students of mine who have spent 2 million rupees from NUS with a wonderful degree, and they are working in call centers. Universities do not guarantee you success. The subject that you study doesn't guarantee you a job. It is only going to be you. How you are. How you present yourself to the world. How much life skills you have. How much confident you are that you can stand up and you can talk to 100 people, 200 people and present. People will pick you. Professions do not have futures. This is one of the biggest misunderstanding in our mind. Professions do not have future. Individuals have got future. Whether you're a doctor, whether you're an engineer, if you are confident, if you can look at the world looking in the eye, you can talk good, you can present good, the world is yours. And even if you go to the best university you want, if you do not have those communication qualities, what can I say? Yes. Any other question? Yes. The concept of black hole is basically every universe, every galaxy that you see, either it's a spiral galaxy or an oval galaxy or a gaseous giant, it revolves around its central core. That central core, for example, in the case of our Milky Way galaxy, is star Sagittarius A. Sagittarius A is such a big black hole. Let me give you a concept of black hole. A black hole is an immensely small but immensely dense object that has got so much of gravity that it doesn't let even light come out of it. I'll give you an example. If this is metal, no matter how much hard I press it, I cannot squeeze it into a small ball. Even if a tank goes over it, it won't be able to make it a squeeze into a small ball. But the concept of black hole is if the whole Earth is squeezed down to a golf ball with the same matter of the Earth, it becomes a supermassive black hole. The gravity of the Earth will be so strong, it will be just a small ball, but it will still hold the moon into orbit. It will become a black hole. Force of attraction same, but so immensely packed that matter loses its properties. You fail to explain what is inside a black hole. So this is what the concept of black hole up till our understanding is. Yes.
We know that the black hole sucks everything inside it.
Yeah.
And the Jupiter, the red dot, the red galaxy also sucks everything inside.
In Jupiter, that big storm that has been there for around 200 years or so, it's basically a gas giant. It's not a black hole. And what it does is that it's such a big tornado type storm, bigger than the Earth itself. That small dot, because the Jupiter is quite a massive gas giant. It's not basically a gas black hole, it's basically a gas giant, right? It's basically a small star that failed to ignite. So it has got nothing to do with the force of attraction. It's basically a gas storm that is brewing over there. Anyone else?
We have heard about dark matter. Like everyone says dark matter exists, but no one has seen it. Like what is this?
That's also called as the mysterious matter. The dark matter or the dark energy coming out of the dark matter is that there are stars and there is space in between the stars. And that space, they say, is not just the space or the vacuum. We normally call it vacuum, space vacuum. It's not vacuum, it is dark matter. And it has got its own energy as well. So, science is still trying to explore what is inside the dark matter. In my book, I said that the dark matter is basically the whole dark matter is photonic in nature. How it is photonic in nature, I will try to explain that in the book. Do read it. If there are more people interested in getting the books, I will get the books over there in the principal office. Yes?
When the black hole sucks a thing or a planet inside it or anything, then where does it go?
Nobody knows. It gets squeezed into certain subatomic matter that where science fails. Science cannot explain the thing that what happens to the thing once it crosses the event horizon of a black hole. The event horizon is that we can only see the thing going past the event horizon into the black hole, but what happens to that thing inside the black hole, the science fails to tell us. Because all of the laws of physics inside a black hole fail. They don't tell us. The laws that you study, they are only applicable to the physical world around us. But once you go to the concept of the black holes and the multiverse, they fail to understand.
No one knows that what is this.
No one knows. Hypothesize. This is where we make our own hypothesis. That this might happen to it. This might happen. Because when I say, if you can squeeze the whole earth into a golf ball, the first question that comes to your mind is, how can someone squeeze the earth? Because this is where the law stops you from thinking. But this is what happens in a black hole. It gets squeezed to such an extent. For example, iron. You know, iron that you use, there is a lot of iron and the metals over here. Iron was not made on earth. Iron was made in a supernova. Iron that is there on earth wasn't created on earth. It was created in a supernova. It was created in an exploding star, and then it came to earth. And in Quran it is written that हमने लोहे को आसमान से उतारा. Science proves things. That's one of the reasons that it is our duty to understand these things. Water didn't, originate on earth. Earth was a part of the sun, the matter. It was so hot, the water couldn't stay. First it got cooled, and then water came in the form of small meteors raining down on earth for millions of years, and then the earth got covered in oceans. So we need to understand these concepts. We need to understand our religion. Yes?
What is the supernova?
A supernova is one of the ways in which a star dies. For example, I'll tell you how the sun is gonna die. Once all of the hydrogen is converted into helium, the sun will start expanding 400 times its original size. It will eat up Mercury and Venus, and it will come near to the earth. This is what science tells us. Still have 30 minutes, right? So I thought that you were getting late perhaps. So this is another concept that is guaranteedly told to us by science, that this is the way the earth is gonna end on the day of judgment. Because when it is said in the Quran that the sun is gonna be so near to you, science proves that this is how the sun is gonna end. The sun is gonna expand 400 times its normal size. And supernova is another way in which a star bigger than the sun will end up, and that is after contracting. It will contract. The sun is gonna contract then, and it will become a white dwarf. Once it becomes a white dwarf, that's it for the sun. But for stars bigger than the sun, they contract to neutron stars. Once they become neutron stars, or pulsars, they emit a lot of radioactivity, and then they explode in supernova. Once they explode in supernova, elements like iron, that they are made over there. Yes. Yeah. When all of the hydrogen. Right now the sun is in the middle of it. The sun is normally thought as it is in the middle age life of it. But God knows how much hydrogen is there in the sun.
We have also learned about galaxies. We only know about one galaxy, the Andromeda.
Andromeda.
And
Yeah.
what is the Alpha Centauri then? The Alpha Centauri. Is it a star or is it also another
That's
galaxy?
a star system. That's a star system. And that star system is inside our galaxy. That star system contains 3 stars. 2 stars very close to each other, and the third star a bit far off. So that is the star system, binary star system. We call it binary, where 2 stars are rotating around each other.
How many galaxies have been so
Billions and billions in observable universe. When we say observable universe, it means that there are billions others we can't see. When we say observable, for example, if I am standing on top of a mountain, I look around, then I say this is the observable land. But I can't say this is the earth, because earth is much more than the observable land. Right? I say this is observable. So the universe is much bigger than the observable things that we see. And most of the galaxies are moving away from each other and from us in such a speed, sometimes it is referred to more than the speed of light, about more than the speed of light. I think this is where we unfortunately have going, because that's the clue for me to wind it up. Right? So inshallah next time perhaps I'm going to come, and once you have gone through the book you can ask me more questions. That's good, as some of the students have really asked a lot of questions. And thank you so much for coming over here. I think you can go. Welcome. You are most welcome. Once we have an observatory in IMCB Pakistan town, you are most welcome to come over here.
Sir, will you get these books? Time travel?
It starts from 20,000 and it goes up the more that you can spend.